Yeah, great to see so many people here interested in our presentations. And we've got incredible speakers here. And this one is not only a good friend of mine, he's also a great artist. And his company is one of the co-founders. His company is doing the most incredible work I've ever seen. So a lot of creative people that do so much super high-end stuff, really. I don't say that often. It's really high-end. And he works with Cinema 4D exclusively with some external renders, and that's why he's going to show Cinema 4D in conjunction with Arnold. So please have a very warm welcome to Mr. Manuel Casasola Merkle.
Hello. Hello, thank you very much. So hello and welcome to the Maxon booth. I'm very glad to see you all here. And today I want to speak about Arnold inside of Cinema 4D. Initially we thought I will do this yesterday, but we had to switch. So now I will explain to you the benefits you get from using the new Arnold Cinema 4D to Arnold bridge. Arnold is a renderer that's around for quite some time. I encountered it for the first time in 1999 when I saw on the internet animation called Pepe with a little red figure, and it was the first global illumination animation I ever saw, because back then there was no global illumination in normal 3D packages like Softimage or Cinema 4D. And then suddenly this animation popped up, and it was so realistic because it had color bleeding and GI, and we were all really flattened while looking at this. And thought, back then we thought, would this be great to have something like this inside of Cinema 4D? But then a lot of years went by without any Arnold integration. Arnold was known as a renderer for big Hollywood productions. Movies like Elysium or Gravity are rendered exclusively in Arnold, and Arnold was only available for big studios for a long, long time. That's because Solid Angle is a small company, or was a small company, and they developed for studios directly and just did not have the resources to support a big market. But this changed, fortunately, not last but not least, because of an artist from Munich, where I come from, who really desperately wanted to have Arnold inside of Cinema 4D. And that's why he hired a developer just to create a prototype, whether it's possible to do so. And it was possible. And he took his prototype and went to Solid Angle and showed it to them and said, look, we have Arnold running inside of Cinema 4D. And they really were excited about this and embraced it and bought it from him and integrated it into Cinema 4D, and now we have Arnold inside of Cinema 4D. Arnold is a very special renderer because Arnold is a ray tracing engine. That means if you're using V-Ray or advanced render, you are used to do a lot of fakes. You calculate irradiance maps and you calculate pre-passes for subsurface scattering and stuff. And with Arnold, this is not the case. The beauty of Arnold is that it's a ray tracing engine. That means every rendering effect there is just ray traced. So that means you can throw everything at it, whether it's volumes or subsurface scattering, refraction, reflection. It always uses the same technique to render the stuff. And that means the only artifact you get is not flickering or anything, but only noise. That means if you shoot a lot of rays, you get a clean image. If you shoot few rays only, the rendering is very fast, but you get noise. And that makes the whole rendering process very fast and very easy. And that's the main advantage of Arnold. It's in my opinion, the easiest renderer out there, because you don't have to have a deep understanding what's going on inside of the rendering engine. Where do I calculate what, and how do I use the pre-pass with the final gathering method like in Mental Ray or something. The only thing you have to care about is how many rays am I able to pump into my scene in the available time. And if I have more time, I can use more rays, and this will give a better image. But before I switch to Cinema 4D and show to you how to use Arnold inside of Cinema 4D, let me first show my showreel, such that you know who I am and what we do at our studio. sound. Sound would be great. Or should I sing while looking at this? I assume we have a problem with sound. But it's all about the images anyway, so please have a look at the images. Ja, ja, ich habe ihn aber volle Pulle gemacht. Naja, probier's nochmal. Ist egal, den schauen wir so an. Okay, you have to imagine that I have that we bought a very, very customly made sound on top of the showreel, but unfortunately the PC doesn't want to play it for some reason or the other. So basically, Aixsponza is a graphics boutique in Munich, a visual effects shop, and what we do is a lot of TV commercials, trade shows, fairs, game cinematics, stuff like that. What we do not is feature film, just because doing feature film is not that easy in Germany, because we have no big studios there, and we are quite busy doing this kind of stuff. What you can see here. One of our biggest clients used to be Red Bull. Maybe one or two of you have seen the Red Bull animations we did some years ago for the Formula One. And of course, we work a lot for car manufacturers like BMW or Audi, because all these are located in southern Germany, where we are located, which is a nice coincidence. And the last project we did was a seed project that is shown here on the Maxon booth all the time. And this was a free project and was a lot of fun to do, because for the first time in years we had no client, which is a special idea about what we should create, the freedom to create something on your own, on our own. Okay, the music you did not hear was by Heck, and the show really is finished now. So please excuse this mistake. Nothing I could do about this. Okay, the first thing is, if you want to use Arnold, you buy a license. The good thing is, the licensing process is quite straightforward, so no need to install a license server or use a dongle or something like that. It's just you buy a license, you get a code, you put it into the plugin, and it runs. At least if you are using a node-lock license. If you want to use floating licenses, they are a little bit more expensive. Then you could put them on the license server, and every computer in the network can access them, as long as only one computer uses them at a time. So let me switch to Cinema 4D and show you where you can find Arnold. In the plugin menu, if you installed Arnold, you get a new menu called C4D2A. And this holds a lot of special Arnold objects. But the main place where you can find Arnold is, of course, in the render settings. It's exactly the same as with every external renderer inside of Cinema 4D. Here under the render menu, you find, in this case, NVIDIA iRay, Octane Render, and Arnold Renderer. If I click on Arnold Renderer, the scene renderer is switched to Arnold, and now I get here on the right side different tabs holding all the options from Arnold. And the first thing that you can see here is that it's only 5 tabs. Other renderers really create a huge bunch of tabs. And this is a hint that Arnold uses only very few settings, and that means for you that you only have to learn very few settings to control the engine. What I can tell you is that these tabs here, system, AUVs, diagnostics, and override, are really not that important. You don't need them very often. What you really use is this main tab, and this main tab only. And it's very interesting because the first slider here, it's called Camera and AA. This is the main control slider for Arnold. So if you don't like to learn the new engine, what you can do is just work by using this slider. If you put the slider to the left, Arnold will shoot few rays. It's very fast and it's grainy. If you put it to the right, rendering gets slower and better. It's really that easy. If you want to dig a little bit deeper, what you can do is you can use all the other controls to tell Arnold exactly which kind of rays to shoot, and you can optimize your scenes a little bit to make them render faster, but it's not necessary to do so. So if I create just a cube, what I have to do now is go to the Cinema 4D to Arnold menu and create an Arnold light, because Arnold at the moment does not support the Cinema 4D headlight that is standard in every scene. And that's because Arnold works exactly the same in all DCCs. So it's available for Houdini and Softimage, Maya, everywhere you can use Arnold. And the behavior is the same as in these other programs, because Arnold comes from a studio environment, and the most important thing for them is to offer a consistent workflow. That's why no headlight is supported in Cinema 4D. It's not that they don't want to do it, it's by purpose like this. I move this Arnold light to the right, and now I will show you the most interesting new feature that Arnold brings to Cinema 4D. And this is called the IPR window. So if I go to the plugin menu and open the IPR window, what you see is that you immediately see something. This is the interactive preview renderer. And this is really a godsend, because what this means is that you don't do your classic workflow that consists of changing something, doing a test render, wait, change again, do a test render, wait. This here reflects immediately all your changes you do. So if I now move this to the right and move my light around, you immediately see the effect this light has. I can go to the light itself and up the intensity or change the color. As you can see here, you see the changes reflected immediately in the IPR. And this is true even for very complex scenes. And this really makes all the difference, because creating good 3D scenes is all about iterating. You do a lot of iterations, and the more iterations you do, the better your scene will get. And with this technology, it's possible to do a lot more iterations. Just think about if you have the task of lighting and shading a car. The main thing with shading a car is placing rectangular lights such that they reflect nicely in the hood and in the paint of the car. And that is so easy with the system that you never want to go use anything else if you once use this. Then there is, of course, the Arnold tag, because Arnold comes with a lot of settings. So if I go to Cinema 4D tags, you find the Arnold's parameter tag, and this holds all the Arnold specific parameters for subdivision, compositing effects. All this stuff is bundled in this tag. And the good thing about this tag is that it's intelligent. That means you don't have a bunch of different tags for different objects, like a camera tag, a light tag, and special compositing tags, but you just have this Arnold parameter tag. And it automatically understands which object it's applied to. And if you apply it to a camera, you get the camera options. If you apply it to a standard object, you get the compositing options. That is really very handy. So you have this tag, and you have this menu here that's offering a lot of different tools for different aspects of Arnold. But to be honest, most of these tools are convenience. So you don't need them for rendering. It's just that they make stuff easier. So let me open one of my demo scenes and show you the basic workflow of Arnold. This is this scene here. It's not very pretty, but I built it because it's useful to show the rendering concepts of Arnold. Because it has glossy surfaces, it has refraction, it has GI in there with color bleeding. The blue table is bleeding on the background and all of this. That's why I built this scene. And I opened this inside of Cinema 4D. Here is the scene. Here is the scene. And if I now open the IPR window, you see immediately that it is rendered. I can move my camera around and see the results immediately. So the main rendering controls of Arnold are here in this window, as I told you. And what you can see here, the first thing is a sampling section. And this sampling section tells Arnold how many rays to shoot. And the rays are in categories. So there are rays for rendering the anti-aliasing, rays for rendering the diffuse effects, the glossy effects, and so on. So that means if I turn all this down here to 0, what happens on the right, everything turns black. And that is because now I told Arnold not to shoot any rays. The only ray Arnold shoots is one eye ray per pixel. That means it shoots one ray, finds a surface, and calculates the surface color. And that's why I only see direct lighting here. I have an area light out of the scene, and this is what is seen here. So if I now want to allow for more effects, what I do is I go up with my diffuse rays to 1. And you see, this is 0, and the shadow behind the table is black. As soon as I go to 1, the light, the diffuse rays are introduced into the scene and create this diffuse effect in the background. And at the moment, I'm shooting one ray for the diffuse effects. That means it's very grainy. If I want to enhance the diffuse rendering, I can go up with my diffuse rays here. If I go to 2, it's not as grainy anymore. If I go to 3, the grain is even less. The same holds true for glossy, and glossy is the Arnold term for reflections. So all reflective effects, whether they are specular or blurry, are summed under the word glossy. If I turn this on, you see immediately appearing the glossy effects, because now Arnold is allowed to shoot glossy rays into the scene. And the same holds true for refraction. If I turn this on, all the glass windows become transparent, and for subsurface scattering and for volumes. Because even subsurface scattering is ray traced by Arnold. So it uses the same ray tracing kernel to do subsurface scattering. That means no baking, no point clouds, and no flickering in animation. Just turn it on and it works. This is the main place where you can control Arnold. And what you do is you analyze your image, and you have a close look to your image, and you have to look at it, and you have to see where is the grain. And then you have to understand, where does the grain come from? Is it grain from the global illumination? Is it grain inside of the blurry surfaces? And then you up the amount of rays on the effect you see the grain coming from. And this is how you slowly reach the level where the grain is acceptable, and this is your final image. This is the process of rendering with Arnold. And in my opinion, it's very easy to work like this, especially as you see the changes immediately inside of the IPR. The next thing that is a little bit important, that's why I'm mentioning it, is the ray depth controls, because the first section is about how many rays are shot into the scene. So this is the quality setting. And the next section is how often these rays are allowed to bounce. It's exactly the same as with refraction inside of Cinema 4D. If you have a labyrinth of glass cubes and you allow for 400 levels of refraction, it will render forever, because the rays are bouncing and bouncing around without any end. And you can limit this. And you can do exactly the same thing inside of Arnold, but you can do it for every ray type there is. That means if you have a look at the image on the right inside of the IPR, if I, for example, go to 0 with my diffuse effects, my diffuse is gone again. But this time, because rays are shot into the scenes, but they are not allowed to bounce, so I have no diffuse. If I turn the bouncing to 1, I have the effect of global illumination, but I have no color bleeding from the table. Usually there should be blue color bleeding from the table, but because the rays only bounce once, there is no color bleeding at the moment. If I go to 2, you see the color bleeding appears. Exactly the same thing holds true for the glossy effects. If I go down with the glossy effects, everything is black. If I go to 1, the glossy surfaces are showing, but the reflection of the glossy sphere inside of the glossy surface of the table is not there. And this is due to the fact that the glossy rays are only allowed to bounce once. So after determining how many rays you shoot, what you do is you determine how often these rays can bounce, because the fewer bounces you calculate, the faster the rendering gets. It's really easy like that. A processor cycle is always the same speed on your computer, and that means to optimize the scene, you have to lower the operations, the calculations Arnold has to do, and these are the controls to do so. So this is the basic concept of rendering in Arnold. The next thing is shading, of course, because a renderer is always only so good as the shaders are. And shading in Arnold is a little bit different than inside of Cinema 4D, because Arnold offers something a lot of you are wishing for years now, that is a node-based material system. And this node-based material system is, again, Arnold feature that is present in all the other DCCs, so it was the most reasonable thing to do to bring it to Cinema 4D. Let me open the scene that shows the standard shader. So here is this blobby object I created to show you the standard shader. And if I open the IPR window, it takes a little bit of time to export the high polygon count model. And as soon as he did it, he will start rendering. Here it is. Now it renders. So what you do if you want to shade inside of Arnold, you go to Shader, and you find the Arnold shader network. And this is all there is. This is basically the Arnold material. But the material works a lot different than inside of advanced render, because it's not a material with a lot of layers that you can turn on and off, but it's only a container for the Arnold shader network. I already created such a network, and if you open this, if you click the material, you get this button exposed, open network editor, and if you click this, this is what you get. Unfortunately, Solid Angle decided not to create a new type of editor, maybe ported from Softimage or something, but they support the node-based interface that you are used to while using Espresso inside of Cinema 4D. So the usage of this is very straightforward. It works exactly the same as an Espresso interface. On the left, you have a list with all the nodes available. On the right, you have an attribute manager, and in the middle, there is a nodal workspace. And what you see here is really the most simple network possible. Let me just reorder the windows a second. This is just an image loader node. That means here I bring in my texture map. And this here is a standard shader. And the standard shader, fortunately, allows for all the rendering effects you know from an advanced render material. So most of the time, you don't need to use the network editor at all, because all the effects, as you can see here on the attribute manager, are already there inside of the standard shader node. It is capable of rendering diffuse, specular, reflection, all the things you are used to are inside of this one node. So basically, normally you use the node and that's it. So if I go here and open the diffuse tab, what I can do is I can change the weight of the diffuse, and you see that I can immediately control the weighting of the diffuse. And this weight works a lot like Adobe Photoshop. You can see the diffuse as a layer, and this weight is a layer transparency. So if I turn down the weight, the diffuse gets more and more transparent until it vanishes. Then the same holds true for the other rendering effects. Here is the specular. I can change the color, for example, to red. Then the specular highlights are red. And I can use the weight to turn it down, turn it up again. Then you have reflection. This is basically the same like glossy, but it's implemented differently. It's a little bit faster. And for special cases, you can use this reflection tab. Then you have refraction. If I, for example, turn on the weight of refraction, you see the object getting transparent while being diffuse. If I now go to diffuse and turn down the diffuse value, now I have a transparent reflective object, and I can put in an IOR value, and then I have a glass material. So it's very, very straightforward to work with this, although you are using nodes. A good thing about this stuff is that this is programmed quite intelligently, because if you click the material here in the attribute manager of Cinema 4D, what you see is this shader menu. And what this shader menu allows you to do is you can select every node inside of the container, and if I do so with a standard shader, it exposes all the parameters of this node to the topmost level. That means if you do so, you can work with this Arnold material exactly the same way you did with Cinema 4D materials. You have all the slots here, everything is layer-based, and it's not nothing new, basically. But if it's not sufficient to do that, you always have the possibility to go inside the node graph and use the most complicated node networks there. And another very good thing is that all the shaders inside of the node network are Arnold nodes. They are only wrapped into an interface inside of Cinema 4D, and that means you can use all the Arnold shaders there are. Or if you find a Maya Arnold shader or a Houdini Arnold shader you like, you can just install it to Arnold inside of Cinema 4D, and it will create a node and you can use it straight away. So it's very compatible with other DCCs, and it's very flexible. The next thing I want to show is a standard case of shading, the car paint shader. A lot of render engines have this. The Cinema 4D Advanced Render, for example, has this since R16, where they introduced a layer-based specular model. In V-Ray, you have different layers of reflection, but in all other renderers, this effect has to be coded into the renderer. In Arnold, this is not the case. In Arnold, there is no such thing as a car paint material or a multi-specularity material, but it is built inside of the shading network very easily. So that means here's a scene with a here is the scene with a car paint shader. What's going on here? Please let me drag this. Here's the car paint shader scene. Let me open the IPR. After taking a moment, you see the car paint shader rendered. And this is the classical use of the shading network. So let me quickly open the shader network. Here it is. And what you see here is a network that is a little bit more complicated than the original network. What I have here is I have two standard shaders. One standard shader is a gloss layer, and the other one is a base layer. Metallic car paint materials are made up of two layers. They have one coating of paint that is very blurry, and then they have a clear coat on top of this. So I recreated this exactly like in the real world inside of Arnold. And what I have here is two standard shaders. And what I can do to show you this, and this is very handy too, I can just connect this to the output port, and you see just this layer. This is the base layer of the car paint, and this here is a gloss layer of the car paint. And these two are just mixed together. Here is a mathematical mix node, which take the input of one node stream and the input of another node stream and mix them together, half and half. And by doing so, I get these layered reflections where you have the glossy, blurry reflections on layer 1 and the specular reflection on top. This is really very versatile. And I see people do a mistake here a lot of times because they think they have to add the reflections on top of each other. But that's not correct, because in reality, you have always to think about energy conversion. A photon is a photon. That means if the photon is reflected, it's not there to go into the material. And if you add reflections, the material will emit more energy than it absorbs, and that's not physically correct. That's why I mix the two layers together. Down here, I have another approach to exactly the same shader, where I use add operation. If I connect this here, you see it's exactly the same thing. But this add operation is only correct because I went in here under specular and turned the weight down to 0.5. So basically, it's exactly the same. If I first make it half transparent and then add it together, it's the same as if I make it full transparent and then mix it. So there are different ways, and this is why I show it to you, to build a shader like this. And the good thing is, once you build a shader like this, you can save it to the library and reuse it whenever you like. And here's another thing that is very, very powerful about a nodal shading network. I have 4 nodes here using the same color. And it's tedious to go into every single node and change the color. But inside of a nodal network, that's not necessary, because I have this flat node here. It has a color, and it goes into all these other nodes. And if I go in here and change the color, all the colors of all the nodes change at the same time. And this is the beauty of the nodal shading approach. Okay, the next thing is, whenever you're using third-party renderers, it's not only about the power of the render engine, it's about integration. Because if the engine is not well integrated into Cinema 4D, you cannot unleash all the power it has. And the good thing about Arnold is that it's very, very deeply integrated into Cinema 4D. One example for this is the Mograph shaders. If you use a cloner, you are used to using the Mograph shader inside of Advanced Render. That way you can use a random effector to apply different random colors to your objects, and the Mograph shader picks these colors up and renders them directly without the need for assigning a single shader to every single object. And this is perfectly possible inside of Arnold, although Arnold does not support the Mograph shader, because they support something much more powerful. Let me show this to you. What I did here is a standard Mograph setup. I used our Aixsponza logo as a texture source, and I created this scene here. And if I open the IPR window, you see, after a little bit of preparation, this image rendered. So basically what happens here is the shader effector uses the Aixsponza logo to apply these colors to the object. And then I bring these colors to the Arnold shading environment through the use of a user data shader. So let me open up the shader to show this to you. So what happens here is I have this node. And this node is called user data shader. And with this user data shader, you not only are capable of rendering Mograph, but you can use all the user data there is. So every value on your object can be used for shading. That means you can create a scene with trees, for example. You can create a color field in the user data, and then you can put one and the same shader on all the trees and vary the color through this color field, and the render engine will pick it up and render the effect directly. This is a special case with the color of the Mograph cloner objects, because what the cloner internally does, if I quickly press convert here, we close this, what you see is the cloner creates a lot of objects, and all it does is, here it's black, but if I find some of the other objects, I don't know where, it just puts the color it creates into this display color field. And this display color field is read by Arnold, and that's why the effect is possible. And to do this, the only thing you have to know is that this display color field is called display_color inside of Arnold internally. You can look this up in the documentation, and then you can read this color in. And this not only works with Mograph, it works with everything. If you decide to do an Espresso network or a Python plugin or I don't know what, you can set all your colors on your objects and can use the user data shader inside of Arnold to pick up the data and use it directly. And I think this is a very nice addition because it gives a lot of power to you, because Arnold is capable of reading all the data from your scene and using it in the shading context. But it does not stop here. User data is per object. That means you can define colors per object. But if you want different colors, you have to split the objects. But Arnold does not stop here, because it can read Cinema 4D vertex maps. And vertex maps are big arrays of float values, so a single value per point. They don't encode a color. But what you can do is what I did here. You can use a gradient to remap these values to color, or you can use just 3 vertex maps and treat one vertex map as R channel, one as B channel, one as G channel, and then you can define color on points by vertex maps and use them inside of Arnold. This is something very powerful. This is a photogrammetry scanned rock. That's why it takes some time to open. No, I think something is wrong here. Oh no. What's going on? Hello. My OpenGL display is letting me down. No, here it is. This is a rock. Has quite a few polygons. And what I did on this rock, it's a rock I showed you here. It's 1 second before it explodes. It's very hot inside. What I did was I wanted to use the curvature information to do the shading, and this is a very usual technique, especially for I don't know, robots or something where you want to have worn edges. What I did in this case was I exported the rock to Houdini and created a digital asset in Houdini that calculates the surface curvature and creates vertex maps for me. And I brought it back in via the Cinema 4D Houdini engine, and this way I had surface surface curvature calculation. But unfortunately, this calculation does not take place inside of the Arnold network. But that's not a problem, because what the engine does, it brings in this. This is the standard Cinema 4D vertex maps that encodes the information from Houdini. And what I can do then inside of Arnold is, it looks a little bit confusing, but it is not. Here is this vertex map shader, and all you have to do to use it is drag the vertex map to this field here. It works by name, and it will find the vertex map and render it to color. And using this, I can use the curvature information from Houdini to shade my objects. This is very powerful too, because it's not only information from Houdini. There is, for example, this stretch tag inside of Cinema 4D that creates vertex maps by examining the tension in your objects. Or you can paint vertex maps, or you can create vertex maps programmatically. So this link to be able to use vertex maps directly in Arnold is very powerful and very needed to really integrate it into the software. Then, of course, the big topic of skin shading. We use this a lot in the Seed movie. A skin shader is basically 3 layers of subsurface scattering and 2 layers of reflectivity, because the human flesh or the human skin is made up of different layers. First, there comes the flesh that is very has a lot of blood and is very red, and then come 2 layers of skin. And to mimic this, a skin shader has to do exactly the same thing. And you can perfectly build a skin shader with standard shaders in the shading network. But because this is such a common task, Arnold provides you directly with a very capable skin shader. I prepared a scene for you showing this. This head is from IR Technologies. They are a photogrammetry scanning studio based in the UK, and were kind enough to provide this head free in the internet. A lot of people downloaded it probably, and I used this for my skin shading example because it comes with all the maps necessary for the skin shader. So let me quickly open the IPR window. After rendering a moment, we will see what Arnold does. And there it is. It's really quite quick. And what you can see here, it's just one skin node. And this skin node has a lot of layers. There is the SSS layer, the shallow scatter, the mid scatter, and the deep scatter. These are these 3 layers for the dermis, the epidermis, and the flesh layer beneath that. And you provide different textures to these 3 layers. But you don't have to. Even if you use the standard colors that come with Arnold, the results are very photorealistic. And then there are 2 layers of specularity, because skin is very oily. And that means you have first a very blurry layer of specularity, just as with car paint, and then a little bit more harsh layer of specularity. And all of this is already built into the skin shader. You just create one of these nodes and can create a very realistic skin shading, as you can see here in the IPR window. So, good thing to have a skin shader. If you want to change something with the skin shader, because you have a nodal network, what you can do is you can build it on your own. You can alter it in any way possible. You can use the skin shader from Lagrange, and the possibilities really are endless. Then there is architectural renderings. A lot of people are doing ArcViz, and for this, and not only for this, HDR environments are needed a lot. And Arnold makes it very easy to work with HDR environments too. So this is the next scene I prepared for you. I open this one, and it renders immediately. It's just a standard ArcViz scene with a little bit of furniture. But what I wanted to show you is this one here. This is the Arnold Sky object. And this Arnold Sky object does all the work for you. So there is no need to load in different images to different places of the renderer, like the environment channel, and then create a skylight and create a HDR light and I don't know what. But the only thing you have to do is you create one of these objects. This is one of the convenience objects I mentioned earlier from the menu. And then you go to backgrounds, and you can change here the type between sky and physical sky. Physical sky is a physical sky model. You find it in a lot of renderers. It's PDAM, I think. And sky means you can load in an HDRI. And what Arnold internally does is it creates a skylight for you that uses this image, and it creates a background shader and all the stuff necessary such that you see your HDRI image and it lights your scene, and it's optimized to be as fast as possible. The only thing you have to do manually is you have to read the resolution here, and fortunately Cinema 4D gives you a hint how high the resolution is, and put it in here to this field, because Arnold uses a technology called multi-importance sampling, and that means that it shoots the rays to the HDRI where they are needed. It analyzes the HDRI and finds the spots where it's very bright, like the sun, for example, and then shoots more rays to this spot than to other spots that are not so important. And by doing so, it can save render time. But to allow for this procedure, you have to tell Arnold how big the image is. That is the only thing you have to remember when working with a sky object. Then something very special, because a lot of you are using X particles, I think. A lot of people use thinking particles or even the standard particles in Cinema 4D. But there is one big drawback with using particles in Cinema 4D. If you want to render them, you have to instance geometry to the particles, if you are not using a specialized solution like Krakatoa or something. And that means you have to create a lot of polygons to render particles. Not so with Arnold, because Arnold has native particle rendering. That means it can render particles as primitives directly in the core. Everything that's going to Arnold is only the positions of the particles, and all the geometry is created on render time. And that means it's very, very fast, and it supports particle color, which is not the case with thinking particles inside of Cinema 4D. But as Arnold is so deeply integrated, it's possible to read every data channel of the particles. So if you create a data channel on thinking particles of type color, Arnold can just read it and color the particles accordingly. Let me show you this scene, because it's astonishingly fast. Where is my cursor? So here is the scene. It's a thinking particle setup. Let me quickly change the settings to ticks such that you can see them. This is what I did in Espresso. Let me quickly open the setup. It's a standard thinking particle setup that imports an image and creates particles on a plane, and then samples the color from the image to the particles. So I have 200,000 particles in the scene, sampling the color from an image. And then I can create an Arnold TP group object, give this a thinking particles group, and if I now open the IPR, boom, there you have it. And it's really, really fast. And that is because Arnold does not need to export all the geometry to the renderer. All it exports is just the particles and creates the particle color and the particle geometry inside of the render engine. And that means if I move my 200,000 particles here in the viewport, you see that the IPR is reacting immediately. It's as fast as the OpenGL display. And this is this is a huge thing, because it really enables rendering of huge amount of particles directly inside of Cinema 4D. With depth of field and motion blur and everything, by the way. And then another technology that comes to Cinema 4D through Arnold is volume rendering. Cinema 4D does not support volume rendering natively. There is plugins like Turbulence FD that do volumetric effects, but basically it's not possible. But in the last years, there emerged a technology called VDB that is open, that is open source, and it's embraced by a lot of programs, like, for example, Houdini. And using Arnold, that means that you can go to Houdini and create a volume, or real flow, or whatever you like. And then you can load this volume directly to Arnold inside of Cinema 4D, and you can render volumes directly inside of Cinema 4D. So another feature that was not there before is volume rendering. I open the scene and you see immediately the renderer starts to render the volume because it's exactly the same thing as with the particles. No geometry has to be passed to the engine whatsoever because the VDB is stored on disk and the structure of VDB allows the renderer to just load the data it needs. And that means the rendering starts immediately. And Arnold has a very nice volume shader. So if you open the network, it's quite easy. It's called the volume collector. And it has all the effects you would expect from a volumetric shader, like scattering, attenuation, emission, and so on. So it's very easy to use. The ones of you that are used to Krakatoa are at home immediately because it's basically the same controls. And it renders volumes very realistically, including global illumination and global illumination scattering effects inside of the volume, and basically everything you can imagine. But it does not stop here. Because we have a procedural shading network here, what we can do is we can use Arnold to sample the volume at different positions. What I did here is I created a noise node. It's just a noise shader as you are used to inside of Cinema 4D that creates a three-dimensional noise. And then on this volume collector, I have this position port. And what this position port means is that's the position where Arnold looks for the volumetric data. So if I put this three-dimensional noise into this position port, what happens is that I generated a procedural cloud immediately. Because now the positions where Arnold looks for the data are transformed by the noise, and this leads to a volumetric cloud. So rendering volumetric clouds aside of pure cluster inside of Cinema 4D is now possible with Arnold. And as you can see, it's quite fast, although it's a volumetric effect, including GI. And the possibilities are really there. And unfortunately, I cannot show this live here because I have no license of Turbulence FD running. But the good thing about the Arnold integration is that they are embracing third-party plugins. Not only are they supporting X particles, but they are supporting Turbulence FD directly. And that means that you can create Turbulence FD simulations and render them in Arnold directly, including all the other objects, all as one pass, including all the goodness of Arnold volume rendering, like GI scatter and all of this, and the speed of Arnold. So it really works beautifully together. And that makes Arnold a nice tool for visual effects. And then we have procedurals, and procedurals are a very interesting approach. Most of you probably know about render instances, and render instances means that the geometry of an object is shared across different transforms. But procedurals is more than that. Procedurals is a complete Arnold scene that can be exported to disk and then used for rendering. And this can not only happen inside of Cinema 4D, but in every program that supports Arnold. So what you can basically do is you can export a model or even a whole scene from Houdini or Softimage or Maya and render it directly inside of Cinema 4D and the other way around. So you can really work with different applications at the same time. Let me show this to you. So what I have here is a cloner, and inside of the cloner I have this Arnold procedural object. And I pointed the path of the procedural object to the AS file I exported earlier from Cinema 4D, where I had this birch tree. And if I now open the IPR, here are my birches. But the good thing is, this is a procedural. That means, again, I don't have to export data from Cinema 4D to Arnold. And that means if I go to the Mograph cloner and up the count, it reacts immediately because the model is already there. And not only the model, the shader, the displacement, everything is inside this archive. and you don't have to care about this. For shared workflows, that's a godsend, because the modeler or the asset artist can finish his asset, including shading and everything, give it to the lighting TD, and the lighting TD can pick up where he left. And it's really faster than the OpenGL viewport to use Mograph here. And I can go up to 1000 with no problem whatsoever. And I can move, while rendering the final image, I can move my camera with 1000 heavily displaced and textured birch trees here in my renderer. That is a lot faster than the stuff you know as render instances, and it's a lot more flexible. This really, I found this shocking when I saw it for the first time. But it does not stop here. Arnold has a system for AUVs, which means arbitrary output variables. So it can really render out all the data that is inside of Arnold as different passes very easily. It's well prepared for compositing applications, and it offers a lot of standard parsers like normals and stuff, but you can do whatever you like. Everything you have in your shader network can be output to a render layer, and with a new take system, which is compatible with Arnold, it's even better than before. It renders hair natively, so this is not polygons, but it has a primitive for hair. It's ridiculously fast. It does motion blur very, very well. And last but not least, it not only blurs all the objects inside of Cinema 4D, whether they are deformed or have changing point count, or it doesn't matter. It even blurs particles. And it does not blur them in straight lines, but if you have a close look, you see it even blurs them in curved lines, which is very important for particle blur. So you see, I'm quite excited about Arnold. I used it for half a year now at the studio, and I really like this engine. And I would encourage you to go to the Solid Angle website and download the demo. It's unrestricted. The only thing you will encounter is a slight watermark in the rendered images, but it's fully functional. Just install it. It's very easy, and play around with it and see whether you like it. So if you have any questions, I will be around. Just approach me, and I will be happy to answer your questions. Thank you very much for coming, and have a nice IBC.